we're looking for when are these quadratics equal to 0? What are the x values when the y is equal to 0? What are those x-intercepts of your quadratic? So we have this first one. I have negative 4x squared plus 144 equals 0. So we saw a couple examples like this yesterday. How did we go about solving this quadratic? Or what could we do in order to try to solve this? What? So actually, these ones are a little bit easier then. We actually don't have to factor this one at all because we only have to factor if it has all three terms in it. So if it has the ax squared plus the bx plus the c, this one only has a and c, and so we actually do not need to factor this one. So that would be easy. So instead, because we don't actually have to factor, all we have to do is get that x by itself. So I can subtract the 144 from both sides, and that'll give me negative 4x squared equals negative 144. And then I can start solving for that x. So I'll get rid of my negative 4, get rid of that coefficient. 144 divided by negative 4. I'm trying to think what that is off the top of my head because I can't remember. It should be, I think it's 36. Yes. And then how do we get rid of the square? What's our inverse operation for that? Inverse operation for x squared. Square root. Good. So we'll take the square root of each side. And now cancel out our square, and we'll just have x. Is that our only answer?
No, there has to be 2.
So it doesn't have to be 2 solutions, but whenever we take the square root, we're going to get 2 numbers. We're going to get a positive and a negative. Now, if we had 0, the square root of 0 is just 0. You can't have positive 0, negative 0. So that's an example where you might only have 1 solution. But for most of these, you should end up with 2 answers. So positive 6 is 1 solution, and negative 6 is another solution. So those are both of our answers. Are we okay with that? All right. Now, this one, we only had a and b. Or I'm sorry, we only had a and c. We only had that first x squared term, and we only had that term without the x. This one, we have all 3 terms. So now we're going to have to do that factoring method. We're going to have to draw our x to solve this one. So what do I do now that I drew my x? Where do I go from here? Negative 3 goes on the bottom. And then my last number, negative 4, will go on the numerator. Because I don't have that number in front of my x squared, I can do that quicker, faster method. So I need 2 numbers that multiply to get negative 4, add to get negative 3. Positive 4 and negative 1. So if we had positive 4 and negative 1, would these add together to get negative 3? No, but they multiply to get negative 4. So we're close. What can we do to change this up a little bit to get the right answer? If we switch the negative, if we make it a negative 4 and a positive 1, negative 4 times 1 gives you negative 4, but negative 4 plus 1 gives you negative 3. So that will be correct. Where do I go from here? So x minus 4 and x plus 1. And because this quadratic up here was equal to 0, this is the exact same thing. It's just a factored form of that quadratic, so it's also equal to 0. So we have 2 pieces multiplying together equals 0. So what we talked about yesterday was the 0 product property. So if both of these multiply together to equal 0, that means at one point, either of these has to be 0. So that means at some point x minus 4 is 0 or x plus 1 is 0. So we're going to get, once again, 2 solutions to this, when x minus 4 equals 0 and when x plus 1 equals 0. So you're going to break it up into 2 problems. How can I solve this first one? The x minus 4 equals 0? Inverse my negative 4 with a positive 4, and so x equals positive 4. Same idea with the other one, inverse negative or inverse the 1 with a negative 1, so x equals negative 1. And so these were the things that we talked about yesterday. How do we feel on this at the moment? Okay. So it was factoring just like what we were doing last week, except we stopped here last time. So the only thing that's different is you split it up into those two pieces and you solve each of them separately. So subtract inverse your 4, inverse your 1, and then you have your two solutions. So I want you to take a moment and I want you to do this first one. Don't worry about the second one. Just try to see if you can factor the first one, set it equal to 0, and solve. Just like what we did on that last problem. So you have x squared plus 7x minus 8. Okay. So for this, we should have created our x. We had negative 8 on top, 7 on bottom. We found 8 and negative 1 multiply to get negative 8, and they add together to get 7. So we were able to factor our quadratic into 8x plus 8 and x minus 1. Those were our two factors we have. Because our original quadratic was equal to 0, we were able to set these factors equal to 0 using our zero product property. So we have x plus 8 equals 0 and x minus 1 equals 0. And then from there, we have now two problems that we have to solve. So we subtract 8 to get x equals negative 8. We add 1 to get x equals 1. Are we okay with that? All right. What's different about these two problems?
That one is going to be a long set, and then we're going to
So this one, we have to do the longer method because it has that a in front of the x. So we're going to see, okay, how is this different? How am I going to have to solve this one? It's really not any different because, once again, the only thing that we are adding on is once it gets equal, or once we get those factors, we just have to solve the factors. So that's really the only thing that's going to change. We just have to remember how to do the long method to get to this part, and then just do that extra little tidbit. So we always started with our x. What went in the numerator, though? What was different about that? What went in the top behind? We took that first number and that last number, we multiplied them together. So 2 times 9 is 18, and then negative 9 goes in the bottom. So we need to think. Two numbers that multiply to get 18, add to get negative 9. Two numbers multiply to get 18. So we need them to multiply to get 18. So let's start thinking of what are some factors of 18.
2.
3 and 6. Can we somehow use 3 and 6 to get negative 9? Negative 3 and negative 6. So negative 3 and negative 6, they multiply together to get 18, a positive 18, but they add together to get a negative 9. So as soon as we figured out what those factors are, we then split our middle term. We split the middle, so we have 2x squared minus 3x minus 6x plus 9. So we split that middle term, that 9x, into a negative 3x and a negative 6x. What did we do next? We want to group first, but then we'll find what our GCF from each of them. So we'll group our first two numbers. We'll group our last two numbers. And now we'll look for what goes in that first group, what goes in that second group. Good. So looking at my first group of 2x squared minus 3x, do we have a GCF? The 2 doesn't go into 2 and 3. There's just an x. So that first group will always have an x no matter what. And that last group should never have an x in it. But because there's no GCF of our numbers or our coefficients, it's just going to be x. So if we factor out an x, we have 2x squared. I'm sorry, not 2x squared, just 2x minus 3. Do we have a GCF of our second group? 3. So I'm going to factor out 3. So negative 6x divided by 3 gives me negative 2x. And then 9 divided by 3 is 3. What do you notice? Are they the same?
No, because the positive 2.
We have our flip sign. So once again, anytime that happens, just change your signs. Instead, we're now factoring out a negative 3, and so that'll change our following sign. So now we have positive 2x minus 3 and a positive 2x minus 3. So that should be the same. There we go. What are our two factors then? So x minus 3 and 2x minus 3. So basically we got to this part. So just like before, because this whole quadratic was equal to 0, I know these factors also equal 0. And then just like what we did over here, I can set each one of those factors equal to 0. It's the same thing, we just add two methods of factors. And so that means x minus 3 equals 0, and 2x minus 3 equals 0. And now that I'm at those two pieces, I just have to solve each of those little equations that I created, and I'll be done. So x minus 3 equals 0, I just need to inverse my 3. And x equals 3, that is one of my x-intercepts. 2x minus 3, because I have that leading coefficient, that 2 in front of my x, it's going to take an extra step, but nothing we can't handle. So plus 3 plus 3, that gives me 2x equals 3. And then I just have to divide by 2 to get x by itself. And so x equals 3 over 2 or 1.5, however you want to write it. Same thing. And those would be my two factors. So these problems might feel a little long, just because we have to do that whole longer method, and then we have to add a little bit extra. But the more you get used, the more we practice with them, the more we use them, the quicker those methods will become, and the quicker these steps will occur. Even though they do have sometimes a couple steps to them. How are we feeling on this at the moment? Following along, doing okay? All right. Do you want to try one of these longer ones on your own? Try factoring it and then try solving it? Seem okay?
Yeah.
All right. See if you can do this. See if you can do that first one. And then we'll talk about the calculators next. All right. We're going to talk about this one really quick, so we still have enough time to be able to talk about the calculators. So we can split it up. We put our two numbers multiplied on top, so that's 14. Middle number in the bottom is negative 15. Two numbers multiplied to get 14, add to get negative 15, is negative 14 and negative 1. So once we get those two factors, we can then split our middle term. So 2x squared minus 14x minus 1x plus 7. We rewrote that whole thing because we split that middle. Now I can group my terms. So I group my first two, and then I group my last two, plus in the middle. And I look for my GCF. My GCF I found in my first group. They both have a 2 in them. They both have an x in them, so I can factor out a 2x. Factoring out a 2x leaves me with just x and then minus 7. If I look at my other terms, they don't really have a GCF in them, so I can factor out a positive 1. That leaves me with just negative 1x plus 7. But I have an x minus 7, I have a negative 1x plus 7, so I know those are flip-flopped. So rather than factoring out a positive 1, I need to factor out a negative 1. I'll make that a positive, and then I'll make this a negative 7. So I'll have to put those signs there. So my two final factors that I got from my split the middle, my long method, was our 2x minus 1 and x minus 7. And this whole thing, of course, is once again is equal to 0. So I can set each of those factors equal to 0. So we have 2x minus 1 equals 0, and x minus 7 equals 0, and we just need to solve each of these. For my first one, I'll inverse my constant. So I have 2x plus 1, and then divide by my coefficient. Ooh, that's supposed to be a 2. So x equals 1/2, or x equals 0.5. I'm sorry, my pen's freaking out again. And then this last one, I just have to inverse my constant because I don't have a coefficient. And so x equals 7. So at 7 1/2 would be the 2 points at which your graph would cross that x-axis if you were to graph it. Are we okay on this? Any questions over the steps we took on this one? All right, I need everyone to grab a calculator. Okay, everyone should hopefully have a calculator. On, I believe it was Monday, we were using the graphing calculator to look at what some of these quadratics look like. So if we hit y equals, once again in the top left corner of your calculator, we can then type in that quadratic and we should be able to graph it. So you can type in 2, our x once again was right next to our alpha button. So we'll do 2x squared minus 15x plus 7. So we can just type 2x squared minus 15x plus 7. Don't worry about the equals 0 part. We can type that right in. Plus 7. That same quadratic we just solved on the board. So you can put that under the y equals. If you hit graph, then you should be able to see what that quadratic looks like. Once again, we just found, using that method on the board that we just did, we found that it hits the x-axis at 1/2 and 7. And so if you look at your graph, it should be crossing the x-axis once again at 1/2 and 7. Should be those 2 points. So let's say we didn't know that it was 1/2 and 7. Let's say we haven't solved that problem yet. We want to be able to do that on this calculator. So what we're going to do, once you have that graphed into your y equals, hit the second button, the blue second button, and then right next to graph it says trace. We're going to hit that trace button. So second trace should be to the left of graph. So second trace. If we look down, the second option on there is 0. We want to go to 0 because we want to figure out when is this quadratic equal to 0. So we'll scroll down 1 and hit enter at 0. And it's going to show a picture of your graph, and it's going to say left bound question mark. What this left bound and right bound mean is we are looking for a point on that quadratic that is just left of your graph, or just left of where it crosses that axis. So we probably have something like this right now.
No, mine's perfect.
Mine's perfect.
Mine's coming.
You can only see one side.
I got that.
If your windows are off, if like you're having trouble seeing the whole quadratic, hit zoom. It's in the middle. All right. So probably yours was graphed. Someone probably changed the windows, and it's probably just still working for you. If it is weird, hit zoom 6, and it should fix your graph. It should center it back on a 10 by 10 grid.
Mine's still perfect.
I still can't see the rest of them.
We typed this one in.
Yeah, I still can't see all.
Can you not see the bottom?
No.
That's okay. Did you put this one in your y equals, Ashton?
Yeah.
You put this one in your y equals? Yeah, that's probably why. You're probably using our graph from yesterday.
Yep.
So you might not be able to see the bottom. That's okay. It might just be just this part, and that's fine. So, it should be asking when you do the second trace 0, it should say left bound. What that left bound is it is asking you to pick a point that is just left of where that graph crosses the x-axis. So we're trying to figure out what are these points. So we need to pick a point. It'll give you a little tracer. You need to pick a point that is just left of where that graph is above across the x-axis. So just left of that would just be just above that point. So move your tracer to a point that is just left of that where it crosses the x-axis. Hit enter, and it will then ask you the same thing. It will ask you right bound. So it's asking what is the point that is just right of that x-intercept. So just right of that x-intercept will be down here. So we'll scroll over right till we go across the x-axis. And now I'm going to hit enter at a point that's just right of that. It's then going to say guess, and you'll hit enter again, and it should tell you where that x-intercept is. It should say x equals 0.5. Hold that. So we went to second, we went down to 0, and here, so to the left of that, left of that, we're across the x-axis. And we're going to go right of that, across the x-axis. Yes. X is 0.5. That's what we got. So when it says guess, hit enter one more time and it should tell you x equals 0.5. That was the same answer that we had for one of those x-intercepts that we just solved for. You can do the exact same thing again to find your x-intercept for the other one. If you hit second trace again and go down to 0, we can do it for the other x-intercept. So you have to scroll over to the other half of the graph. Too far. So once again, it'll ask you for a left bound. So you want to pick a point that's just left of that x-intercept, and you'll hit enter. It'll ask you for a right bound, and you'll pick a point that's just right of that x-intercept. Hit enter. And then you can hit guess, or enter again, and it should tell you, oh, x equals 7. So x equals 0.5. And x equals 7. Those were the two answers that we just had doing all that math on the board. We can also find them using these calculators. So it takes a little bit of getting used to the buttons and what they're actually asking for and what you're supposed to be doing with the calculators. But once you get familiar with it, we can do a lot of math very quickly just by having the calculator do all the work for you. All you have to do is just know how to work the calculator. Wow. So if you get familiar with the technology, you can get a couple shortcuts. Also, if we hit second trace again, there's some other parts on there. It says value, it has minimum, maximum. These are some other things that can be useful. So if you want to figure out where's the maximum value or where's the minimum value, it'll ask you a left bound, right bound, and you'll do it right around that maximum or minimum value, and you can find, it'll tell you those coordinates. If you want to find what is the value of this quadratic at x equals 13, you can hit value and type in 13, and it'll tell you, oh, at x equals 13, your y is this answer. And so the calculator will do a lot of the work for you. You just have to be familiar with it. That's why I'm trying to show you this stuff as much as I can before your state test. Because once again, you'll have these calculators on your state test. So if it asks you, one is, how can you solve this? You don't actually have to work through all that thing. As long as you can do it on here, you can solve it much quicker. And we'll practice with this more tomorrow. And we'll practice this step more tomorrow as well. Questions, concerns, comments, beats, rants? All right, if you're done with your calculator, bring it up to the front and put it in the charging port. Now we'll take it from there.
Grab